High performance computing is really to focus on what is the key driver of all innovation or all progress in the world today, and that is Moore's law. And all we're doing is trying to identify the companies that can help extend this relationship. And so when you think about Moore's law, for those people who or haven't heard of it or maybe don't understand it, it really is the process of increasing transistor density on semiconductors. If we go back all the way to 1971, the first Intel chip had roughly 2,000 transistors on it. And over time, it used to double every 2 years. So the 2,000 went to 4,000 and the 4,000 went to 8,000, the 8,000 went to 16,000. And what this meant is over time, computers got faster at an exponentially growing rate because they were able to increase the amount of transistors density on a semiconductor. And as we sit here today, the latest NVIDIA GPUs now have 54 billion transistors on them. And so what NVIDIA is doing is they are effectively becoming an enabler of the speeding up of compute power. And it is this speeding up of compute power that has a twofold effect. One, allows us to do more stuff, but two, it lowers cost. And so if we look at the semiconductor industry over the last number of decades, you can see the whole industry has grown at effectively 8% per annum. And that 8% per annum, while it has many cycles in it, it is a true structural growth area. And what we think now, as cost is continuing to lower and as compute power continues to get better, we're going to move into what we think is effectively a brewing sandstorm of semiconductor demand. If we look at the world, we see the Internet of Things, or effectively cheap devices allowing everything in the world to be connected, whether it's your traffic lights or your car park or your airport check-in or your COVID test. All of these things are effectively going to be connected. And all of that data is going to go up to the cloud. And in the cloud, you're going to use really high-end semiconductors, really high-performance compute semiconductors to process that data to provide artificial intelligence outcomes. And so what we think is this is going to be the key source of comparative advantage in the future. And so if we look at the industry as a whole over a very long time frame, we can now see 4 distinct phases. The first one being the mainframe phases, where computers were effectively in big rooms at NASA. The second being the personal computer era, where you got a computer at home. The third being the mobile computer era, where not only do you have a computer at home, but you had mobile devices and the Internet of Things all around the world connected. And then finally, we're moving into the artificial intelligence era. And so we think this will be the next big inflection in semiconductor demand. And all we're saying when we look at high performance computing is that what are the key companies that are going to enable this big inflection? Because they clearly have structural earnings growth, and that structural earnings growth should ultimately equal structural share price growth.